Hey guys, video for 11.7, which is surface area and volumes of cones. This is very similar than pyramids, except a little bit easier. Just couple vocabs. So surface area, think back to middle school. Surface area would be like if you're painting the object, what part would you want to paint? So it's the area on the surface. And when I say surface, I simply mean the outside of a three-dimensional figure. So like I said, think of like if you're going to paint it. The lateral surface would just be the entire surface minus the bases. So we're excluding the bases. That would be the lateral surface. The net of an object. I'm sure you guys did this in middle school. It's a two-dimensional pattern of a three-dimensional figure that if we fold up, would form the figure. I know if we were in class, we'd have fun with some nets and I'd give them to you and you'd have to like create whatever cube you could with them. Kind of fun, but well. The slant height, guys, would be the slanted distance from the apex, which is also called the vertex, to the base. And we'll do some examples and I'll show you the difference between a height and a slant height here later in this video. All right, so volume of a cone, guys, like I said, it's 1/3 area of the base times height. So volume, 1/3 area of the base times the height. Now, the good thing about it is we have a circular base. So the area of the base will always be pi r squared times h. So this is always your formula, 1/3 pi r squared times h. You know, remember when we're doing this, we want the height, the straight up and down height, not the slant height. Okay, so if we do an example, the volume of this is going to be 1/3 pi r squared. Well, we can see the r is 2.2 times the height, which is 4.5. And when I do this and I plug it into my calculator, I get roughly 22.8, and that's centimeters cubed. All right, similar cones. We've done several of these. You guys should be pros. So the first thing we want to do is we want to find the scale factor in one dimension. Okay, we'll notice your 8 and your 2. So the scale factor in one dimension is 8/2, which is 4. Now we're talking about volume, so that's 3 dimensions. So to find the scale factor in 3 dimension, it's just 4, the scale factor in 1 dimension, to the 3rd power, which is 64. So what that means is that the volume of cone C is 64 times bigger than the volume of cone D. So to get cone D, all I'd do is I'd take the volume of cone C, which is 384 pi, and I would divide it, because it's getting smaller, by 64. And when I do that, I get 6 pi, and we're talking about volume, so it is centimeters cubed. All right, so that's how we do the volume. Okay, let's do the surface area now. So surface area looks a little bit different, okay? So the surface area of a cone is pi r squared plus pi r l, okay? Essentially what we have is this is the area of our base, so that would be the circular base, and then the pi r l would be the surface area of the lateral area, which is everything but the base, okay? This L is our slant height. Don't ask why they use a cursive L, but that's just what they use. And the slant height is exactly what it sounds like. It's the height, but it's slanted, okay? So this here would be the height, which you'd use for volume, but this here would be the slant height, which we use for, which we would use to find the surface area. So the surface area of this cone is pi r squared plus pi r L. Well, as you can see, the radius is 4. So this would just be pi times 4 squared plus pi times 4. The lateral height would be 6. So 4 squared is 16, so this is 16 pi, plus 4 times 6 is 24. 24 pi, which equals 40 pi. And we are surface area. Our keyword is area here, so we're in two-dimensional space, so this would be in inches squared. All right, one more, we'll do a composite solid. Here we have a cylinder and then a cone on top of the cylinder, and we're putting them together. So to find the volume of the composite solid, it would just be the volume of the cylinder plus the volume of the cone. Okay, so we're going to find them separately, and at the end, we're going to add them all together. So let's do the cylinder first. So the volume of a cylinder is always pi r squared times h, which is pi times 6 squared times the height is 5, which gives me 180 pi. Or if you want to put that in your calculator and get a decimal, that's okay too. All right, now I want to find the volume of the cone. So the volume of the cone, the equation would be 1/3 pi r squared times h, which is 1/3 times pi. Once again, our radius, guys, radius of the cone is the same as radius of the space, so it's just 6 still, times the height. So we want the height of the cone, which is 4. So 6 squared is 36. 36 times 4 divided by 3. So I get 48 pi. All right, so the volume of the cone here is 48 pi. The volume of the cylinder is 180 pi. And when we add them together, we get 228 pi. And we're talking about volume, which is 3-dimensional, so we are in meters cubed. If you want a decimal, put that into your calculator. Let your calculator do the work. All right, that was it for 11.7. And I will see you back here in a minute for 11.8.